Okay, so here we've got the notes for section 2, which deals with implicit differentiation. So there are objectives. So implicit refers to the fact that the equation is not defined as a y equals. So that would be an explicit function, y equals some function involving x's, one term for y on the left, only x's and numbers on the right. So this guy here is an example of a implicitly defined function because it's not a y equals equation. So to find this, here is how it works. So when you take the derivative, you do it just like you normally would. The derivative of 2y would be, derivative of y squared would be 2y, but anytime you take the derivative of a y term, you generate a y prime. Over here on the right, you just have 1. Now, y prime is the derivative, it's dy dx, is what I'm solving for. So to get y prime by itself, I'd have to divide both sides by 2y. So y prime is 1 over 2y, which means in this case, the slope of this tangent line is defined by the value of y, not necessarily the value of x. This essentially is like acting like a chain rule, even though it's hidden. The outside is the squared, so 2 comes outside, leave the inside alone, the y, and then multiply by the derivative of the inside, which is the y prime. So this is actually a chain rule step in terms of y. Okay, so 2 says find the slope of the circle, x squared plus y squared equals 25 at the point 3, negative 4. So to find the slope, we need to take the derivative. So derivative of x squared is 2x. The derivative of y squared is 2y, but since I just did the derivative of y, I get a y prime, and the derivative of 25 is 0. So solve for y prime, so I need to move the 2x across. So 2y, y prime is equal to negative 2x. Then divide everything by 2y, so negative 2x over positive 2y, so this is negative x over y. So that's the same thing as m. So my point is 3, negative 4, so this becomes negative 3 over negative 4, which is just positive 3/4. Okay. So example 3 says that the slope, show that the slope dy dx is defined at every point on the graph, which means that we can't have any discontinuities or anything like that. So when you take the derivative, so derivative of 2y is going to be 2 times y prime, because I did the derivative of a y, equals 2x, derivative of the x squared. Now this guy acts like a chain rule. Derivative of sine is cosine y, and then times y prime. So now this case, this term here needs to move to the left. I'm going to stop drawing my multiplication dots. So 2y, y prime, minus cosine y, y prime, we'll leave that one in, equals 2x. So now since I have multiple y primes, I can factor it out, which leaves me 2 minus the cosine of y, and then I can divide the whole quantity across. So y prime equals 2x over 2 minus cosine y. So it says show that defined at every point on the graph. So the cosine here is never equal. So the only way that this equation wouldn't work is if this is equal to 0 on the bottom. But the thing is the cosine never has a value more than 1 or less than negative 1. So it can't get large enough to solve that equation. If you pull the denominator out and set it equal to 0 and try to solve, you would get this. So y is equal to the inverse cosine of 2, which has no solution. So there is no value that makes that equal to 0, which means that this is always defined. Down here at the bottom, we have the steps. So differentiate both sides with respect to x, which is this step here. Take the derivative. Collect the terms dy dx or the y prime on one side of the equation. So that's that step. Get all the y primes left. Factor out the y prime. That's that step. And the last step, solve for dy dx by dividing the quantity across. Okay. So example 4 here says find the tangent and the normal to the ellipse at the point negative 1, 2. So I have my points, so I know my x value, and I know my, y value, but I do need the value of the slope. So slope is the derivative, so take the derivative of this guy. So the derivative of x squared is, so this is m, we don't need to do that because we have an equal sign already. So 2x. Now this is actually a product rule. It's two things being multiplied together. So product rule is derivative of the first, which is 1, leave the second alone, plus leave the first alone and take the derivative of the second, which is y prime. Then plus, this guy is going to be 2y, but it was a y, so y prime, and the derivative of 7 is 0. So do a little bit of cleanup, so minus y, minus xy, y prime, plus 2y, y prime, equals 0. So I need to get all my y primes to the left, which they already are, which means everything else that doesn't have a y prime needs to go right. So this term and this term need to move across. So negative x y prime plus 2y y prime equals negative 2x plus y. So these two terms come right. Factor out the y prime, negative x plus 2y. And the right-hand side stays the same. And divide the quantity across. So negative 2x plus y over negative x plus 2y. So this is my slope. So to figure out the value, I need to plug my x and my y values in. So this becomes negative 2 times negative 1 plus 2. So that's plugging in my x's and y's. And on the bottom, negative 1 plus 2 times 2. So that's, let's see here, 2 plus 2, so that's 4 on top. On bottom, that's 1 plus 4, so that's 5. So my slope is 4/5. Now I can actually write slopes. So for the tangent line, y equals, m is 4/5, x minus x1 plus y1. So that becomes plus because it's a double negative. So 4/5 x plus 4/5 plus 2. So y equals 4/5 x, that's 10/5, so plus 14/5. Mixed numbers are bad, don't use them. For the normal line, so normal line has the opposite reciprocal slope, so negative 5/4, but everything else stays the same. So negative 5/4 x minus 5/4 plus 2. So let's see, that's 8/4, so negative 5/4 plus 8/4 is positive 3/4. So there's the tangent line, there's the normal line to that ellipse at that point. Now you can keep repeating this process. It does get kind of messy, but it can be done. So find the second derivative of this guy. So first derivative, so take the derivative of 1, so that's going to be 6x squared minus 6y y prime equals 0. So remember the y prime shows up beside the derivative of the y. So we need to get y prime by itself. So negative 6y prime and then negative 6x squared. So bring that guy across, divide by that. So it's just going to be x squared over y, because the negative 6's will cancel out. So now to get the second derivative, I take the derivative again. So the derivative of y prime is y double prime equals, so this is a quotient rule, this is u over v. So derivative of the top is 2x times the bottom y minus the top times the derivative of the bottom all over the bottom squared. Now I know what y prime is equal to because I have its formula, so I need to replace this y prime with that. So 2xy minus x squared times x squared over y all over y squared. So clean up, 2xy minus x to the 4th over y all over y squared. So this becomes, let's see here. So we're dividing both of these by y squared. So this becomes 2x over y, because that y cancels one of those out, minus x to the 4th over y cubed, which would be, if I want a common denominator, 2xy squared minus x to the 4th all over y cubed would be your second derivative. Okay, so this is just the power rule again, just a reminder. Okay, and then we've got example 6 here. Let's see if we can do this. So find the second derivative here. So, so that's already y prime. So I actually have this equation. So the second derivative is equal to, that goes away, this becomes sine y, not sine, cosine y times y prime. Through the sine is cosine. Y prime is equal to this, so y double prime is equal to the cosine of y times 1 plus the sine of y. Okay. So let's see here. X equals the sine of t, y equals the cosine of t. So the second derivative here, so dy dx would be the derivative of y, so derivative of cosine t is going to be negative sine t. And on the bottom, it's going to be positive cosine t. So this is actually the negative tangent of t. And then the second derivative would be negative secant squared t. Okay, so if y equals f of t squared and f prime is equal to this, then dy dx, okay? So y prime is equal to, so we take the derivative of the outside, so f prime of t squared times the derivative of the inside, which is 2t. It tells us what f prime is. I feel like there's a typo in this problem. So f prime of t squared would be, I would plug t squared into this equation. So that's 2 minus the cosine of t squared times 2t would be y prime, which brings us to the end of the section.